For the last 30 years, we have lived with a compromise. We carry devices in our pockets that are more powerful than the computers that sent humans to the moon, yet their primary function, communication, is a prisoner of geography. We are tethered to a grid of steel towers and fiber optic cables rooted in the dirt. We've all felt that pang of isolation. You're on a remote highway or perhaps a hiking trail, and you realize that if something goes wrong, you are effectively a ghost. In the tech world, we call these dead zones. The millions of geographic tiles, where towers simply don't reach because it's too expensive, too dangerous, or too environmentally sensitive to build them. Think about the scale of our planet. Despite the 5G stickers on every storefront, over 90% of the Earth's surface has zero cellular coverage. If you are in the middle of the Atlantic, the depths of the Amazon, or even a rural stretch of the American Midwest, you are functionally disconnected from the 21st century. We have accepted this silence as a law of nature. We've been told that to talk to the sky, you need a brick-sized phone with a massive antenna or a motorized satellite dish. But as of 2026, those laws are being rewritten. SpaceX is currently executing the most ambitious infrastructure project in human history, turning the vacuum of space into a global cellular network. This is Starlink Direct. It's not just an upgrade. It is the definitive end of the no-service era. We are moving from a world of patches of coverage to a world of blankets. To understand why this is a breakthrough, we have to look at the physics of the space tower. Usually, satellite internet requires a dishy, a specialized terminal with a high-gain antenna. But your smartphone doesn't have a dish. It has a tiny antenna designed to talk to a tower 3 miles away, not an object 350 miles in space. The engineering challenge SpaceX faced was equivalent to trying to hear a whisper from a person standing on the other side of a hurricane. The secret lies in the Starlink V2 satellites. These aren't just mirrors for data. They are specialized E-Node B modems orbiting at 17,000 miles per hour. Inside each satellite is an array of extremely sensitive, custom silicon designed to hear the faint, low-power LTE signal your phone emits. But the most impressive part isn't the listening. It's the antenna. Each direct-to-cell satellite unfurls a massive 25-square-meter phased array antenna. This is essentially a giant ear in orbit that can focus its attention on a specific tile on the ground. The genius here is that it uses the exact same LTE protocols your phone already speaks. There are no proprietary space chips needed. No firmware hacks. No special apps. SpaceX partners with terrestrial carriers, like T-Mobile in the US, Rogers in Canada, Optus in Australia, and Airtel in Africa, to use their existing licensed spectrum. To your phone, the satellite is just another tower. It just happens to be moving across the sky at Mach 22. The system handles the massive Doppler shifts and the handoffs between satellites in the background, making the transition from a ground tower to a space tower completely seamless for the user. It represents the ultimate democratization of space tech, taking a billion-dollar constellation and making it accessible to a $50 used smartphone. This wasn't an overnight flip of a switch. It was a phased conquest of the dark tiles of the Earth. In early 2024, the world saw the first successful space text. It was a hello world moment that proved the link was stable. By 2025, the mission expanded into voice calls and basic data. Now, in 2026, the service is reaching its stride, integrating into the standard plans of major global carriers. However, we must maintain a realistic perspective. While the space tower is revolutionary, it is not a fiber killer. Because the signal is shared across a massive cell on the ground, often dozens of miles wide, the bandwidth is limited. In the city, your 5G tower might give you 500 megabits per second. From space, you are looking at a shared pool of roughly 2 to 10 megabits per second per beam. This means you aren't going to be streaming 4K video or playing low-latency competitive games from a life raft. This is about essential connectivity. It's about the "I'm safe" text. It's about the voice call to a rescue coordinator. It's about downloading a topographic map when you've lost the trail. There is also the clear sky requirement. While the satellites are powerful, they are whispering from orbit. If you are deep inside a concrete bunker, in a basement, or in a dense urban canyon surrounded by skyscrapers, the space tower cannot see you. It is a technology built for the open world, the mountains, the oceans, the rural plains. Furthermore, because your phone is working harder to shout back to space, users should expect a slightly higher battery drain during active satellite sessions. This is a digital safety net, a tool of resilience, and a bridge for the billions who live in regions where building a ground tower is economically impossible. So, if it's slower than 5G, why does it matter? It matters because of resilience. Our current civilization is incredibly fragile. When a hurricane, an earthquake, or a wildfire strikes, the first things to fail are the cell towers. They lose power, their fiber optic backhaul is severed, or the physical structure is toppled. In those critical moments, the no-service icon is a death sentence. But the space tower is invulnerable to terrestrial chaos. It doesn't care about floods, fires, or power outages on the ground. For emergency services, this is the ultimate tool. Search and rescue missions that used to take days of grid searching can now be resolved in seconds with a single location pin. Compare this to traditional satellite phones, the ones that look like bricks from the 1990s. They cost $1,000, require specialized plans, and charge $10 a minute. Starlink has democratized the sky. By making satellite connectivity a feature of the phone you already own, they have removed the barrier to entry for global safety. It means that no service is no longer a geographic limitation. It is now a choice. From the mountains of Chile to the outback of Australia, every tile on the map is finally getting its signal. We are moving toward a world where the Earth is one single, continuous service area. No more dead zones. No more dark tiles. We have finally decoupled human communication from the limitations of the ground. SpaceX and its global partners are betting that the future of the internet isn't just about speed. It's about ubiquity. But this raises a question for all of us. In a world where we are always connected, do we lose the ability to truly disappear? Does the end of the no-service era also mean the end of true solitude? I want to hear your thoughts. Would you feel safer with a space-based backup? Or do you cherish those moments when the world can't find you? Drop a comment below. If you want to see if your phone is space-ready, check the compatibility guide in the description. Hit subscribe to stay on the pulse of the orbital age. The sky isn't the limit anymore, it's the network.